For thousands of years, Saturn has fascinated mankind with its majestic presence in the night sky, and one of the most striking features of this gas giant is its magnificent set of rings. They are so big and beautiful that they have inspired countless works of art and captured the imagination of scientists for centuries. In recent decades, we have learned a lot about these rings, but many mysteries remain. In fact, the more we learn, the more questions we seem to find answers to. New ones pop up, and scientists wonder, why are there only 7 rings? What are those weird gaps and spokes within them? Is there a simple explanation behind the complex architecture of these rings, or is there something else going on? Welcome to our channel. And today we're going to look at what scientists have uncovered about Saturn's rings and what remains to be explained. You won't want to miss this. So let's dive in. The grand design. We currently know of 7 main rings around Saturn, labeled alphabetically from A to G, with E being the outermost. The rings are intermediate in complexity, halfway between the more extensive set around Jupiter and the simpler rings found around Jupiter's moon Europa and Neptune. Each ring consists of countless small pieces of ice and rock ranging in size from miles to mere inches. The inner 5 rings, A, B, C, D, and E, are opaque and only a few miles wide. The outer 2, F and G, are intermediate in complexity, halfway between the more extensive set around Jupiter and the simpler rings found around Jupiter's moon Europa and Neptune. Each ring consists of countless small pieces of ice and rock ranging in size from miles to mere inches. All 7 rings lie within a plane about 26,000 kilometers from Saturn's equator. However, they are not perfectly round. Instead, each ring is slightly wider at the edges than in the middle. And the reason for this is pretty simple. It's all about gravity. Saturn's gravitational pull is strongest at the center of the rings and weakest at the edges. As a result, the rings are stretched into slightly wider shapes. But if you take a closer look at the rings, you will notice that they are not smooth and continuous, but rather fragmented into numerous smaller segments. These segments are separated by narrow gaps, and some of them even have spokes-like patterns that resemble wagon wheel. So how do these strange gaps and spokes come into being? Shepherd moons. If you look closely at the rings, you will notice that the gaps and spokes are not random, but follow a very specific pattern. For example, the majority of gaps between the segments are caused by small moons known as shepherds that orbit Saturn just outside the rings. These moons act like shepherds, herding the segments of the rings into place. Their gravitational pull keeps the segments stable and prevents them from crashing into each other. In addition, the shepherds also play an important role in creating the spokes within the rings. These spokes are formed when the gravitational pull of the moons creates a temporary gap in the rings. Over time, this gap widens and becomes a spoke. There are many shepherds orbiting Saturn, and they vary greatly in size and mass. Some are only a few miles wide, while others are hundreds of miles across. Despite their small size, the shepherd moons are vital to the stability of Saturn's rings. Without them, the rings would likely collapse into a flat disk. But despite the progress we have made in understanding the rings, many questions still remain. For example, what determines the width of the gaps? Why are there no gaps between the outer 2 rings, F and G? And what is the origin of the spokes? Scientists have put forward various hypotheses to explain these phenomena, but none have been confirmed. Gaps. The gaps in Saturn's rings are fascinating structures that have puzzled scientists for years. They are much wider than the gaps between the segments and can reach hundreds of miles across. One of the most famous gaps is the Cassini Division, which separates the A and B rings. It is over 4,000 kilometers wide and was discovered by the Italian astronomer Giovanni Domenico Cassini in 1675. The origin of these gaps is still unknown, but it is believed that they are created by the gravitational pull of nearby moons. This theory is supported by the fact that many gaps occur near the orbit of a moon. For example, the Encke gap in the A ring is located close to the orbit of the moon Pan. However, The mechanism by which the moons create the gaps is not fully understood. Some scientists believe that the moons directly carve out the gaps as they orbit Saturn. Others argue that the moons merely destabilize the rings, causing some segments to drift into the gaps. Another intriguing aspect of the gaps is their stability. They have remained essentially unchanged for centuries, which is remarkable considering that Saturn's rings are constantly shifting and evolving. This stability suggests that the forces that create the gaps are very powerful and well-balanced. The study of gaps in Saturn's rings is not only a fascinating scientific endeavor, but also has practical applications. By understanding how gaps form and evolve, we can better understand the dynamics of other systems, such as the rings of other planets and the debris disks around young stars. Additionally, the search for new moons and other objects in the gaps could provide valuable insights into the formation and evolution of Saturn and its rings. Spokes. Spokes are another mysterious feature of Saturn's rings. They are narrow, straight segments that radiate outward from the planet like the spokes of a wheel. The first spokes were discovered by the Voyager spacecraft in 1980, and since then, scientists have identified several dozen of them. What makes spokes particularly intriguing is their apparent instability. They often change shape and disappear within a few months, only to reappear elsewhere in the rings. This behavior suggests that spokes are not static features of the rings, but rather dynamic structures that evolve over time. One of the leading hypotheses for the formation of spokes is the resonance instability. According to this theory, the spokes are created when the gravitational pull of nearby moons causes a temporary instability in the rings. This instability leads to the formation of waves that propagate outward from the planet. These waves then interact with the segments of the rings, causing them to bunch up and form spokes. Another hypothesis is the vortex instability, which proposes that spokes arise from the collective behavior of many small particles in the rings. When the particles collide, they exchange momentum, which can lead to the formation of localized regions of high density. These regions then evolve into spokes as they are dragged outward by the rotation of Saturn. Regardless of their origin, spokes provide valuable insights into the properties of Saturn's rings. By studying the behavior of spokes, scientists can learn more about the composition and structure of the rings and the moons that shape them. Challenges and future prospects. Studying Saturn's rings is challenging due to their distance and the harsh environment of space. However, the rewards are great, as understanding these rings can help us learn more about the formation and evolution of our solar system. Future missions to Saturn, such as NASA's upcoming Dragonfly spacecraft, will provide new opportunities to explore the rings and answer outstanding questions. Dragonfly is scheduled to launch in the mid-2020s and reach Saturn in the early 2030s. It will carry instruments to study the composition and structure of the rings in more detail. Moreover, advancements in computer modeling and data analysis are continually improving our understanding of the rings. Scientists are developing new algorithms and simulations to better understand the complex interactions between the rings and the moons of Saturn. Conclusion. Saturn's rings are truly a sight to behold and have captivated humans for centuries. While we have learned a lot about them over the years, many mysteries remain. From the gaps to the spokes, these structures pose intriguing questions about the forces that shape them and their role in the evolution of Saturn. As we continue to explore the rings, we can expect to uncover even more fascinating insights into the inner workings of our solar system. With future missions and technological advancements, we may finally unlock the secrets of Saturn's rings and marvel at the beauty and complexity of our universe. Thank you for watching and joining us on this journey of discovery. If you enjoyed this video, don't forget to subscribe for more updates on all our videos, and if you have any thoughts or ideas on the topic, please feel free to share them in the comments below. We'd love to hear what you have to say. Until next time, keep looking up and exploring the wonders of our universe.